I'm going to use some of this copper pipe to create my terminals on the ends of the battery. The battery terminal posts are smooth, maybe 0.551 inches in diameter. That's I think I put that into a calculator online, and I think that's 14 millimeters. So how do you actually get something to go on there? Well, there's a few different options of what you can do. This is from an auto parts store, and it's a very generic, off-the-shelf battery terminal. The problem is that it's bigger, and so when you go to put it on, you got to really sink that down. There, that's as tight as it goes, and it's not super tight. Now I'm in the US, and our battery posts are bigger than you guys might have overseas. I think a European battery post would actually fit a lot better for this. Or you could pad this out with something, piece of copper or wire or something like that, and then sink it down. Here's another option. This is an electrical lug. I have heard electricians call this a chair lug. So you can kind of see where they got that name. I'm not an electrician, so I don't know the official term for this, but I think these are aluminum and then they're tin plated, and they have an Allen head screw. And you could get, you know, that's a tight fit there, and then you have an electrical connection that you can make. The problem I see with this is there's very little actual contact between the screw and the back side of the circle where it connects up. Now, I don't think there's necessarily anything wrong with this connection if you're not pulling a lot of amps, but as you start pulling more and more amps, that tight little surface contact area is going to get hotter and hotter. So you can kind of see the amount of surface area is fairly small. Alright, so I'm going to make something, and I've got a bunch of scrap pieces of copper, and I've cleaned this one up. You can see what it was. So it's dirty on the inside because it was in use at somebody's house. Because there's a specific diameter that I was looking for. This says 1/2 inch type L. The interesting thing about copper pipe is they all have the same outside diameter, but there's 3 different types. I think it's L, M, and K. L is the medium one, I think. But they come in different thicknesses, and that's the wall thickness. So there's a very thin, a medium, and a thick. Type L is the type that I have here, and it happens to have the right inside diameter. So let's take a look at what happens when we go to put this on. It doesn't quite fit. It almost gets it, but not quite. And the reason is that the inside diameter of the copper pipe is just a hair less than the outside diameter of this, which is actually really good. It means that I can press this on with some force and it's not going to come off. Maybe 0.551, maybe 547 or 548. So you can see it's just a few thousandth of an inch smaller than the post. So it's real close. So it's not going to take a whole lot of force to actually get the copper to expand slightly to get over this post. This piece of copper pipe has red paint on it, and I forget, I think this is type M, as in Mike, and I'm using the blue stripe, which is type L, as in Lima. And so if I put this on the post, see that? Lots of play. That's not going to make a good electrical connection. So the outside diameter of this copper pipe is equal to what I'm using. The inside diameter is bigger, and the thickness of the wall is thinner. That's why you can put it on and it's loose. So don't use the red stuff. It won't make a good electrical connection. Use the blue type L. So I'm going to cut these up into 3-inch long segments. Here's a standard pipe cutter. There's some rollers, and then you have a blade. And what I'm looking for, see, I made a little tick mark at 3 inches. So I'm looking to get that blade lined right up with my little tick mark. And I think we got it. Okay. So this end I deburred, and now you can see the cut end is not deburred. So what we do is we just take this, it's a deburring tool. It has a little curved blade to it. And we put this in the opening, and we're going to rotate it around. It has a little turned in section, And so what you do is you put this in, you just rotate it back and forth. So you just roll this around inside the edge, and you wind up beveling the edge and taking off that burr. But now that edge is nice and curved inward. I have all my pieces of copper pipe cut. They're all 3 inches long, and now I'm going through and I'm just deburring them one at a time, both ends. I have cleaned all the inside by taking a wire brush, and here's what I did. I just took the 1/2 inch wire brush and I just cut it off the handle, and then you can put it into your drill and you can drill out the inside and clean it just like that. No big deal. I've used this brush to clean up one end of all of the pipes, and that's where the electrical connection is going to be made. To crimp this, I have a jaw horse set up because I don't actually own a proper vise. So I'm making do with what I got. The jaw horse has rubber inserts, so that's why I put some aluminum angle in here. And crimp it down. See, I got it lined up with that little tick mark. And it takes 2 steps. We can tell it's not perfectly flat. There's still some air gap in there. Here's my railroad track anvil that I made, and I'm just going to line this up, and I'm going to tap the edges just a little bit. It doesn't take a lot because it's already flat. And now you can see those 2 pieces are squished together the whole way. It's nice and straight. It's in line. So I just took this piece of wood and lined up one of the pieces of copper on here. And I put a few chisel marks in there around that. And I'm making a jig to hold this. Uh-oh. There we go, that one's good. Look at that. 3rd time's the charm. Now it fits in there nice. All of these copper fittings, can't quite get it on there. So how do we fix that? Well, I'm going to be pounding it on, but before I do, I'll be using some of this. Now this is conductive grease. It improves electrical conductivity. So this is different than dielectric grease. Dielectric grease is an insulator. It's meant for the rubber connectors. It's not meant for the electrical connection itself. This carbon grease, this is electrically conductive. Should just come out just a little bit. I'm going to put a little bit inside the copper terminal, the copper pipe here. Okay, now it's a mess. Now I want all of these to be upright. I cut a slot in this piece of wood. Now watch the tips. And it's a little off from straight up and down, so let me try to fix that. Looks better like this. Well, that's the idea. I have 24 of these connections to put on, and I'm really happy with them. I'm excited. I'm gonna finally get this thing wired. It's taking me a long time to get to this point. So thank you everybody very much for watching. If you want to buy some of these, I'd love it if you could use the affiliate link in the description below. That just helps out the channel. And thank you everybody just very much for watching the video. Thanks. At this point I can just take a wire that has a ring terminal on the end and I can bolt this to it, and I can sink that bolt down as tight as I want, not worry about any threads stripping out on me. And I can just attach to the next one. So like this is a positive, I could jump across like this and get my 48 volts out these two terminals. All the cells are parallel together, or excuse me, all the battery modules. So these are paralleled at 24 volts. And I have checked with my meter and I haven't seen more than 3 amps moving between any of them. So I'm just going to leave this overnight